I've noticed a related hack recently in Claude outputs where it's something you can tell it's probably not directly a part of the core LLM, but again, something that they've tacked on top where I'm now frequently seeing in Claude responses things like, this is a relatively niche topic. I don't have that much information. You might want to double check this.
Mhm.
And I find that they're being really conservative with that, where I'm getting that frequently on questions that I ask on things that I don't think are particularly niche.
Yeah.
And so maybe there's some fine tuning that they need to get right there. It seems, that kind of problem seems like something that these big LLM trainers are working at, and they're probably all taking different kinds of approaches. You have actually you wrote on LinkedIn that
Mhm.
you developed an enterprise chatbot that doesn't hallucinate,
Yeah.
which seems related to this.
Mm.
So, yeah, hallucination, having this kind of confidence about things that the LLM doesn't know anything about, it seems like you've achieved something here. So, how did you accomplish this?
Well, yeah. So the only way to make a chatbot not hallucinate is not use an LLM to generate the output. Like we all know that RAG, this retrieval augmented generation, decreases the level of hallucinations quite significantly. So, for example, if you ask about like machine learning and you pulled the data from Wikipedia, the machine learning article, and you answer the user's question based on this Wikipedia article, then the chances that you will say something entirely wrong are quite small. There are still chances, but quite small. For example, I don't know, compare it to just answering out of the box without doing any retrieval. Maybe you will hallucinate 20-30% of time. But with retrieval augmented generation, maybe 1-2%. So it's still there, but not quite a lot. So what we decided to do is we decided to exclude any possibility of hallucination. So basically, our chatbot, it's not the open domain chatbot. This is a very big advantage for any machine learning team when they work with closed domain versus open domain. So, like for example, OpenAI, Anthropic, Google, Gemini, they all work in open domain. There is zero chance that they can create some kind of templates, kind of fixed templates for every possible kind of answers. But if you work with the closed domain like ours, and our SaaS can answer users' questions. For example, what are the top skills for a Java developer in Chicago, or what is the difficulty to hire a registered nurse in San Francisco? So all this information can be directly pulled from our internal APIs. For example, you provide the occupation, you provide the location ID, and you call the API about salary. So it takes your occupation, it takes your location, it pulls from the index the distribution of salary distribution, and then you just show it to the user. So what we decided to do is that we decided to create a set of predefined templates. For example, okay, so you look for a average salary for a nurse in San Francisco. The average salary for a nurse in San Francisco is, and then there is a placeholder for a number, and we pull this number from the API and we show it. So the possibility of hallucination here is zero. There is a possibility of an error in how we interpret the user input. But because we always show all our interpretation, for example, let's say the user says, someone with JS skill, okay? So before we show any number to the user, we need to normalize, we need to convert this JS into our internal skill taxonomy. So we take this JS and we use our internal skill taxonomy, skill normalizer, and it says, okay, JS, it's skill number 1, 2, 3. So we show the user, okay, so you look for someone with JavaScript skill. So the user sees exactly how their input was understood by a machine. And then the user sees the output, and the output also comes directly from the database. So there is no, so the hallucination, it's when you see some number and you are not sure whether this number represents what you asked for or it represents something arbitrarily different from what you asked for. But in our case, because it's a closed domain, we say, okay, so occupation code A, skill number 123, location it's San Francisco, California, US. It's all shown in different. We call them like pills, like they're all normalized kind of labels that you see, and then you see a number. So yes, the number can be wrong, but the number can be wrong not because we made it up, but it's because the distribution of jobs corresponding to your search doesn't reflect the reality. But you would get exactly the same wrong answer if you use the system directly using the traditional UI. So there is a one-to-one correspondence between what you see in the chatbot and what would you see on the platform if you didn't use the chatbot. So this is what we call zero hallucination. But of course, errors can always be there, but some errors we can control, but some they are just come from the data that we gather online, and this data is never 100% perfect.
Right. Of course. Yeah. So that is an interesting approach to avoiding the LLM in order to avoid hallucinations.
Yeah, but sorry, but we use LLMs in the process. So we use LLMs to understand the user input, because the user input is just a string, but we need to convert this string into some structured format, and then every piece in this structure we need to normalize. So yes, the LLMs is used to understand, but not to inform.